The success of Allied air power during World War II hinged on their engine's reliability, performance, and firepower. In this, Pratt and Whitney stood as one of the leading engine manufacturers of the war. Pratt and Whitney produced engines for some of the most famous planes of the war, ensuring air dominance for most of the warbirds that had their engine, from the transport workhorse C-47 Skytrain to the deadly F6F Hellcat. These engines powered planes that continue to inspire people till today. In this documentary, Pratt and Whitney's contributions to the aviation of World War II are scrutinized with engines such as the R-1830 Twin Wasp and the R-2800 Double Wasp taken into consideration. We'll be reviewing these planes, their extraordinary engines and specs, and their role in key battles to learn how these engines decided the war's outcome and enrolled themselves as a major landmark in aviation. As conflict erupted in Europe and the Pacific, the outcome of aerial warfare in 1940 relied on one essential pillar: the performance of the engine. An aircraft's value was dictated by its engine and performance. How reliable the engine was, the horsepower it produced, and its range of endurance single-handedly decided whether the pilot would emerge victorious from battle or succumb to defeat. The United States was looking for plane engines that could excel under challenging conditions for flight. Pratt and Whitney signed a deal with the U.S. The radial engine served as the backbone for American aviation, powering thousands of American combat aircraft. The R-1830 Twin Wasp and the R-2800 Double Wasp were engineering marvels that enhanced speed, altitude, and durability of the machines. These weren't mere components. These were the heart and soul of the pilots, the foundation of America's air might, and the driving force behind victory in some of the most critical battles of World War II. This is the story of Pratt and Whitney engines. These are the machines that drove the fight for freedom. One of the most dramatic shifts in warfare that began with the Second World War was the need for a strong air fleet. World War II was much more than a struggle between armies and navies. The introduction of large-scale air-to-air fighting, strategic bombing, and the deployment of troops via planes during the World War II drastically changed the nature of combat. This change in turn meant that fighters became crucial for winning wars. And as such, immense leaps in aviation technology began to be tackled. At the onset of the war, many countries were still dependent on plane designs made during the intermediate periods. Nevertheless, achieving air supremacy as well as improving logistic efficiency mandated rapid development. Dogfights became the order of the day, and therefore fighters were required to be faster, more mobile, and heavily armed. The range and payload capacity of bombers also had to be increased. This meant that deep strikes into enemy territory could be carried out. Troop transport planes also had to be able to carry men, supplies, and even vehicles all over the world. Every major power scrambled towards producing mammoth quantities of high-performance planes that World War II required. The German Luftwaffe attempted to shatter Britain's defense through rigorous bombing, marking the start of the Battle of Britain in 1940. However, the now famed Royal Air Force approached the fight with Spitfires and Hurricanes, successfully beating back the assault. This conflict revealed how controlling the skies in a certain area could truly decide the outcome of conflict. As with the crucial Battle of Midway, where U.S. Navy aviators defeated the Japanese fleet, aircraft carriers became the new prominent naval power in the Pacific, effectively replacing battleships. B-17 bombers and B-24 Liberators have made strategic bombing a fundamental part of the war effort, attacking enemy factories, railroads, and cities in a crippling move. The ability to weaken the opposing side's industry from the air severely restricted the Germans and Japanese to a more defensive stance. In tandem, massive airborne exercises during the D-Day invasion depended on C-47 Skytrain and other transport aircraft as thousands of paratroopers were dropped behind enemy lines to capture crucial targets. At the end of the war, aviation advanced significantly, setting the bar for modern warfare and civilian aviation. There was a greater need for powerful and dependable aircraft, which later resulted in improvements within the engine industry as companies like Pratt and Whitney met the demands of the war. A German engineer at Blohm and Voss was working on an American engine known as the Pratt and Whitney R-2800 during World War II. He was thoroughly impressed with the precise craftsmanship of the engine, especially the fact that there was no gasket needed. The joining of the crankcase halves was exceptionally well crafted. The same level of accuracy was not found in British or Japanese counterpart engines. Supposedly, he said, "If this is what Americans can assemble in bulk, then the war is lost." Frederick Rentschler, established Pratt and Whitney with the intention of building more powerful and reliable airplane engines in the year 1925. The R-1340 Wasp, a 9-cylinder radial engine, was a massive success and served as the backbone for their first major success. The U.S. Navy placed strong orders for the engine and earned a name for themselves as one of the top makers of airplane engines. They were able to produce massive amounts of 600 horsepower. In the 1930s, the company introduced its Twin Wasp and Double Wasp series, which later helped them during World War II. When the war started, Pratt and Whitney was already well known as a provider for the American military airplanes. At the beginning of World War II, Pratt and Whitney was manufacturing around 5,000 engines per year. By the end of the war, this number increased to 50,000 engines per year. Almost half of all engines used by Allied aircraft were supplied by Pratt and Whitney, which shows the impressive scale of American industrial capacity. The company is famous for its innovations like the R-2800 Double Wasp radial engine, which was claimed to be one of the most powerful and dependable engines ever made. During the early 20th century, aircraft engine technology was categorized into two types. Air-cooled radial engines. These engines were lighter and simpler, but had cooling issues from the start. Liquid-cooled inline engines. These are more sophisticated engines with added features like radiators. In the 1920s, the United States Navy required all their aircraft to be fitted with air-cooled radial engines, which significantly advanced the technology of radial engines. Charles Lawrence's J-5 Warbird was one such innovation. Powered by advanced radial engine technology, it was claimed to be one of the strongest engines with 300-hour operational reliability. Thus, radial engines proved their worth in aviation and served as the power source for Charles Lindbergh's transatlantic flight in 1927. With a staggering 173,000 units produced, the R-1830 Twin Wasp was the most popular aircraft engine ever produced. It had a power rating of 1,200 endurance and performance. The C-47 used it for long-range flights, the B-24 for extended bombing runs, and the F4F during dogfights. It was the best engine made for this time period. It was simply unmatched. The Douglas C-47 Skytrain, very useful for troop and cargo movement, especially during D-Day landing. The consolidated B-24 Liberator, a multi-purpose bomber designed for high-altitude and long-range missions. The Grumman F4F Wildcat, the principal U.S. Navy fighter at the start of the war. The Pratt and Whitney R-2800 Double Wasp was arguably one of the most powerful radial engines built during World War II. With some of the most revered fighters in American aviation history, it served as the centerpiece to many of the most powerful American aircraft. It was an 18-cylinder, twin-row radial engine that provided between 2,000 and 2,800 horsepower. This gave American warplanes the best speed, durability, and power over any opposing forces. Not less than 125,000 units were built, which ensured uninterrupted provision for numerous fighter and bomber aircrafts throughout the war. Aircraft powered by the R-2800. The Republic P-47 Thunderbolt, better known as the Jug. The Republic P-47 Thunderbolt was a single-engine, heavy-duty fighter with immense power. Carrying the R-2800, it reached incredible speeds of 433 miles per hour, while also having the ability to overcome towering heights and high speeds. In addition to its speed, the claim to fame for the Jug was its astonishing ability to withstand extreme amounts of damage while returning burns on the battlefield. While flying the P-47 during the aftermath of the war, pilots had the utmost confidence in its value. The Vought F-4U Corsair, the commander of the Marine Corps in the U.S., did not see eye to eye when it came to the prowess of the bird. Unlike the other nations that the Corsair fought against, the U.S. believed that the F-4U had the capabilities of being a phenomenal carrier fighter due to its unique gull-wing shape, in combination with the over 2,000 horsepower the R-2800 engine produced. With the weight, the Corsair surpassed the Zeros in numbers that have yet to be seen, breaking a stunning world record of 430 miles per hour. The Grumman F6F Hellcat, intended for control of the Pacific, the F6F Hellcat enabled excellent rate of climb and a maximum speed of 376 miles per hour by using the R-2800's power. Designed for roughness and ease of maintenance, it became the backbone of U.S. Armed Forces, recognized with over 5,000 aerial victories, more than any other American airplane. The Navy's air superiority, its blend of speed, range, and resilience, guarantee Allied command of the Pacific skies. The Martin B-26 Marauder. The B-26 Marauder was a fast, medium bomber with powerful armament, operated on two R-2800 engines to achieve speeds of 310 miles per hour. Originally famous for its great landing speeds, later changes increased safety. Its speed and resilience made it a good, effective bomber in the European and Pacific theater. The R-2800 was a genuine game changer, from fighters to bombers, guaranteeing Allied air dominance over several fronts. The last of the piston giants, the R-4360 Wasp Major. Pratt and Whitney created the R-4360 Wasp Major as the conflict approached its end. A 28-cylinder, 71-liter radial motor good for 4,300 horsepower. It drove the Boeing Stratocruiser, as well as the Convair B-36. Large piston engines were soon made obsolete by jet engines. Though Pratt and Whitney engines fueled several of the most powerful Allied planes, the Germans too produced outstanding engines. Featuring direct fuel injection for better efficiency, Daimler-Benz DB605 drove the Messerschmitt's Bf109. Featuring an early engine control unit for easier pilot operation, the Focke-Wulf FW190 uses BMW 801 for running. The Junkers Jumo 211 was key to German bombers such as the Ju-87 and Stuka Ju-88. Still, Pratt & Whitney's engines were remarkable for the dependability and output volume. Whereas the German engines typically needed regular maintenance, Pratt & Whitney's radial designs provided ease of repair and resilience under battle conditions. During World War II, Pratt & Whitney engines greatly assisted in gaining air supremacy for the Allies, delivering the speed, durability, and power required for success. The R-1830 Twin Wasp and the R-2800 Double Wasp propelled some of the most famous planes of the war. Their dependability let pilots fly their aircraft to the edge and get back home intact, thereby essentially determining the course of the battle. Though their contributions to World War II stand as a monument to American engineering and industrial might, Pratt & Whitney's heritage is still evident in today's modern jet motors. The narrative of World War II aviation could have been quite different were it not for those engines.